Hi everyone, and welcome to our video on some exam questions related to electricity. Our first exam question states an electrical circuit is shown in the figure below. The current in the circuit is direct current. What is meant by direct current? So remember the clues in the name: direct current. It's current which is always in the same direction, and that would get you 1 mark. Okay, next question. The equation which links current, potential difference and resistance is given. Potential difference is current multiplied by resistance. We need to calculate the potential difference across the battery in the circuit in the figure above. So remember, it's the total resistance because this is a series circuit. The total resistance adds up, so it's going to be 20 ohms at 10 ohms, which is going to give 30 ohms, and we have the current there, which is 0.4 amps. So all we do is 0.4 amps and we multiply it to 30 ohms. Okay, and you can just type this into your calculator: 0.4 multiplied by 30, that's going to give you 12 volts for 3 marks. Now the next question says we're given another equation of power, which is current multiplied by potential difference. We need to calculate the power output of the battery in the figure above, and we need to give our answer to one significant figure. So we know our potential difference and we know our current. We've just worked out. So the current is 0.4 amps, and then we multiply it to the potential difference, which we've just worked out, 12 volts, and that will give us our power. So 12 multiplied by 0.4, that's going to give us 4.8. So the power is 4.8 watts for 2 marks. Next question. A student wanted to investigate how the current through a filament lamp affects its resistance. Use the circuit symbols in the boxes to draw a circuit diagram that she could use. So the key thing over here, she wants to see, the student wants to see how the filament lamp affects its resistance, how the current, filament lamp and resistance. So we're going to use a battery to start off with. Okay, so we're just going to use a 12 volt battery like this, and then we're going to connect it to an ammeter. Remember, that's in series, and then we have a variable resistor, which is something like this, and then we have our filament lamp, which is like this, and we close our circuit. And remember, we need to calculate the voltage as well, so we're going to draw that in parallel with the filament lamp. So V there, we've drawn it in parallel. Okay, and that would be worth 2 marks. Describe how the student could use her circuit to investigate how the current through a filament lamp affects its resistance. So 2 easy marks that you can easily get is that you could measure the current through the filament lamp. So use the ammeter to measure current through filament lamp. Okay, through filament lamp, and then you can use the voltmeter to measure the potential difference across the filament lamp. So use voltmeter to measure your potential difference across filament lamp. Okay, and then you can, because it's a variable resistor, you can vary the resistance. Okay, so you can, first you can calculate the resistance. You can calculate the resistance using the equation V equals IR. So V equals IR. You can do R is equal to V divided by I, because you know your potential difference and your current, and you can then vary the resistance to investigate how the current changes. And then you can vary the resistance using the variable resistor you can vary the resistance using the variable resistor to see changes in current. Okay, and that would get you 4 marks. Okay, next question. The students' results are shown in figure 1. Describe how the resistance of the filament lamp changes as the current through increases. So as you can see, as the current increases, the resistance also increases. As the current increases, the resistance increases at an increasing rate. As you can see, it's getting more and more. Okay, so as current increases, the resistance also increases at an increasing rate, and that would get you 1 mark. Okay, next question. Use figure 1 to estimate the resistance of the filament lamp when the current of 0.1 amps passes through the lamps. So 0.1 amps is over here, so we need to complete this. So I'm going to try as best as I can. So as you can see, I've just completed the line. So at 0.1 it's there. Let's work it out what it's going up in. So 7 is going to be approximately there, so this is going to be approximately 6.3. okay, so I would say that is approximately 6.3. So as you can see, we've just completed the line of the plots that we've plotted, okay, because we're just estimating the resistance at 0.1 amps. That would get you 1 mark. Next question. The current potential difference graphs of 3 components are shown in figure 2. Use the answers from the box to identify each component. So we're given 3 graphs over here, and we need to identify what is the graph for each component. Okay, so first of all, this, as you can see, as the potential difference increases, the current also increases, but at a decreasing rate. And that is the filament lamp. Okay, remember, the filament lamp heats up, that increases the resistance towards the end. Graph B, it's directly proportional, the current and potential difference. That tells you it's a resistor at a constant temperature. So that means it's not gonna cool or heat up at the end. So it's a resistor at constant temperature. Okay, and that would be worth 1 mark so far for each of them. And then graph C, as you can see, it just goes up and the current only flows in one direction, and that's a diode. Okay, and it would be 1 mark for each of these, so 3 marks in total. Okay, next question. An electrician is replacing an old electric shower with a new one. The inside of the old shower is shown in the figure below. The electrician should not change the shower unless he switches off the mains electricity supply. Explain why. So remember, if he doesn't switch off the mains electricity supply, the one with the current is going to be the live wire, and if he touches it, he's going to get electrocuted. Okay, so he may get electrocuted if he touches the live wire. Okay, and that would get you 2 marks. You need the live wire, that's key detail there, and he will get electrocuted. Okay, next question. The new shower has a power output of 10,690 watts when it is connected to the 230 volt mains electricity supply. The equation which links current, potential difference and power is there. Calculate the current passing through the new shower. So we have the power output and we have the potential difference. We're given the equation, we need to give our answer to 2 significant figures. So we need to calculate the current. To do that, we have the power, which is in the correct units, 10,690, divided by the potential difference, which is also in the correct units, 230 volts, and that's going to give you the current. So 10,690 divided by 230 is going to give you an answer of 46.47826 and so on. It says to two significant figures, so it's going to be 46 amps for 4 marks. Final question: the new shower has a high power rating than the whole shower. How does the power of the new shower affect the cost of using the shower? So because it's a new shower, it has a higher power rating. That means that more energy is being used per second. So what's it going to do? It's going to be more expensive for 1 mark. More expensive because more energy is being used per second. Okay, and that would get you 2 marks. And that is it for this video. Thanks for watching. I hope you liked it. And one last thing, please subscribe, hit the like button and the notification bell.